What's going on, folks? All right, so we got 1 more minute to start up on class. We've got our students in here, and I've got an awesome program I want to share with you guys and have you guys use because we're going to be doing physics experiments on this. By the way, where are you guys in math class? Because remember, the whole point of what I'm trying to do here is to help you out with your math course. Yeah. So I was trying to help you out with like quadratic equation. The other day I showed you where the quadratic equation comes from. No, we're not doing, well, we kind of are doing math, but we're kind of not doing math today. I'm going to start showing you programs, and I'm still going to be hanging out because I feel like where you guys are at in your math course I feel like where you guys are in your math course is like angles and geometry and lines. Is that right?
Yeah.
Where you guys have like this thing called opposite interior angles and all of that kind of stuff?
Yeah.
All right. It's not that doesn't interest me. That interests me a great deal. But I feel like you've glossed over parabolas a little too quickly for my taste.
Yeah, I think we did like 1 week on that.
So I'm going to spend pretty much the rest of our time together on teaching you guys some really cool applications to the math that you've learned. That's actually my goal. Okay? So we're not doing math directly today, but we kind of are. And I'm going to show it to you guys in a way that might actually be like, well, I didn't realize that was math. But hey, that makes a lot of dang sense to me. We cool? All right, let's get this party started. What I'm going to do is I'm going to have everyone download this program called Tracker. Here's the link for it. Don't download it right now because it's only going to slow down your computer. But let me show you what it looks like. If you go to that link, it'll bring you to this one. This is a video analysis program, and it's actually really cool. You can pay lots of money for it, or you can get it for free. This is the free version. Actually, to be honest with you, the free version is better than the paid version. I've tried both of them. I know, it trips me out too. Anyway, if you guys are Mac people, download the Mac OS X one. If you're Windows people, download the Windows OS X one. If you are Linux people, then you guys know more about computer programming than I do. So you download whatever it is you want to download. You crazy people, you. All right. And don't restart your computer. Don't restart your computer now if you download it now, but I just told you not to download it now because it's only going to slow down your computer. So download it right after school. And yes, for the school computers, we're running Windows unless you are one of those lucky few who got a Mac from the school, which I haven't heard of anyone who's ever been that lucky. I've never been that lucky. I want a Mac, and they gave me a Mac desktop, so I guess I'm happy with that. All right, whatever. All right, so you download this thing, and I'll show you the program, and that's what we're going to do today. We're going to be playing with this program. And what's really cool about this is I'm going to let you guys track your own videos. So you guys can record videos and track them. And so what you can do with this is, who plays sports? Do you play sports?
I do. Yeah.
What do you do?
Paddle, surf.
All right, you're a surfer? Okay.
Surf and swim team.
Your swim team, all right? All right, so let's talk about swim team man over here, right? We can actually set up a video camera, video you swimming across the pool, and analyze the speed and where you speed up the most and where you slow down the most and where you get tired and all of that kind of stuff. And we can actually improve your technique by looking at that, by analyzing that kind of stuff. We can analyze your baseball swing or your volleyball, or your basketball shot, and we can see what angle you shoot it at. And in fact, I'm taking a test, by the way. And so like I told you, I can't stay because I'm taking the test. And you get your own handwritten notes. These are my handwritten notes, 100 pages, buddy. And it's all this crazy stuff, math. Like it was that soap film stuff that I was telling you guys about. You guys remember the last time we hung out? It was like I was talking about like the soap film and all that kind of stuff. And what I started doing is I started realizing that I can actually calculate for you guys the optimal angle at which you should shoot a basketball with according to your height. Like what angle should you do in order to give you the best percentage of getting a shot? I mean, that's pretty cool. And I mean, I'm not going to teach you that kind of math, obviously, because I mean, it took me like 10 years to get to that math. But what I'm going to do is I'm going to teach you how to analyze it. That's pretty cool. So that's what this program does. So after you learn how to use this program, you can apply it to anything that you want. In fact, your assignment for this week is to apply this video analysis program to a video that I gave you, and it's a really easy video, and then you make your own video and analyze that. Are we cool? So instead of just talking about it, and this is due next week, Monday, I believe. So I'm giving you a week to do it. So instead of just talking about this thing, why don't I just start showing you how to do it, how to use this program. So I'm going to do a new one. I don't even want a new tab. I just want a completely new one. Well, there's a new one. Let's just go. All right. So when you open up the program, it looks like this. Okay. Now what we need to do is we need to download some kind of video file for us to do. So whenever you take a video, and by the way, does anyone not have access to a video camera? Like your phone would do, GoPro, a video camera, a regular digital thing, an iPad works perfectly fine. All of that stuff works fine. Is this program free? Yes, this program is absolutely free. Jing works as well. I'm just wondering if all of you guys have at least access to a video camera. I'm assuming that everyone does. I don't think that anyone doesn't have a phone that can't record video, or at least their mom doesn't have a phone, or dad doesn't have a phone that doesn't record video. Yeah, flip phone would work, all of that kind of stuff. As long as it spits out like an MOV file or a AVI file or a video file. It's pretty much all the files that are video files. I don't even, yeah, it tracks a whole bunch of, here, I'll show you. It uses all of these, MOV, AVI, FLV, MP4, WMV, etc. So all of those ones, if it spits out any one of those, then Tracker can track it. All right. The next part of this assignment, and actually, you know what? Watch what I'm going to be doing today, because what I'm actually going to do is the first part of your assignment. I'll show you what's going on. I have this thing called Assignment Tracker Introductions, Part A and B. In class today, I'm pretty much going to do Part A for you. And then for Part B, it's just one paragraph long, and that's what you guys get to do. It's basically, your assignment is to do the exact same procedures as above, only now you're going to use the own video you make yourself with your own video camera and you know, some way to track it and all that kind of stuff. Try your best to capture blah blah blah. Okay. I also need to include instructions in here. Make sure to include some kind of calibration step.
What does that mean?
You don't know what it means now, but you'll know what it means when I finish my lecture today. Sound good?
Yeah.
All right. So, part one, we need to download the file called Dunebuggy, and I think that you can click on this link and just download it straight, or you can download it right off of the website, dunebuggy.avi. Here it is, and it's downloading, and it's done. All right. Now, what I ask you to do is I ask you to open that file inside of the tracker, but you know, another easy way is just to grab it and drag it straight in. Boom, it's done. It downloaded. There's the Dunebuggy. You guys want to see it? We are tracking that. How interesting. It's a little toy car that moves across the screen and is moving.
So, like, how do you tell things with it?
Is it interesting? Is this video interesting? No, not really. Yeah. It's kind of cute, right? All right. Anyway, let me show you guys some cool stuff about it, all right? No, don't be sorry. Just I mean, yeah, whatever. Okay. You know, this is the only thing I could find that moves at a constant rate. You know what I mean? Because first thing I want to do is I want to start baby steps. I want to talk about moving at a constant rate. And we'll call him Jeff. Sure. This is Dunebuggy Jeff. All right. So what we need to do is we're going to track this thing, and I'll show you guys some cool stuff. Let's see if we can get this thing a bit bigger. All right. Because we can actually track basketball, you know, shots and all of that kind of stuff. We can track like track stars and running and all of that kind of stuff. We can track swimming, surfboarding, all of that. Spear fishing. We can track like how fast your spear goes.
I can shoot my spear gun and then.
Yeah, you can track the end of your spear gun, and then have that stuff. You see what I mean? So there's some techniques that I need to tell you guys on how to track things. First of all, is I like to have a calibration stick in there because obviously this isn't a real car, right?
Right.
This isn't a real car on a table, but the computer doesn't know that. You could actually take a video of a real car, and the computer would say, "Oh, hey, there's a little, it looks like a car going across the thing, but I can't tell if it's a real car or a fake car or whatever." So in order to tell the computer how big something is, you need this thing called a calibration stick. And what that means is do you guys know what this thing is in this picture right here is?
Yardstick?
It's not a yardstick, it's a meter stick.
Oh, meter stick.
It measures out a meter.
Isn't that basically 3 feet though?
So I'm gonna make this thing called a calibration stick. You guys see it?
Yeah.
And I'm gonna tell the computer that from there to there is 1 meter. Wait, 1. So from there to there is 1 meter. Are we cool?
Wait,
So that way the computer knows, hey, if from here to here is 1 meter, then this must be a toy car because like when I compare this thing to the size of what an actual meter is, you know what I mean? Then it says, oh, this is a toy car. I know, I understand what's going on now. But you have to tell the computer, hey, from there to there is 1 meter. We cool with that? All right. Now, next thing we need to do is we need to tell the computer where 0 is. In a sense, we're setting up what we call a coordinate system. You guys know what a coordinate system is, right? You got the X going horizontal and the Y going vertical. Well, look, there's your coordinate system. I can move this coordinate system anywhere I want. So why don't we move it to the beginning of the meter stick, right there. We cool? That is now at the beginning of the meter stick, and that is, that's where, right here at that square right there, that's where x equals 0, y equals 0. If I'm at some point over here, that's where x equals something, y equals 0. You guys know how to, I just set up a Cartesian coordinate system, just like you guys do in math. Are we cool with that? All right, is this cool yet? Is this interesting? Not really. No? Alright. Anyway. Why do I need this program? I love your question. Because here's what this program can do that you can't do with other programs. I'm going to track. I'm going to create a new track. And I make all these instructions inside of this thing over here. Alright. Wait, what's the pink line? The pink line is your x and y coordinate system. So here's the positive x direction, and here's the positive y direction. It's just like the x and y that you would use in math. And when you give me coordinates, you would tell me the x comma y. It's just like that. And what I'm going to track is I'm going to track this car. But the way I'm going to do that is I'm going to track 1 point on this car. I'm going to track, here, I'll show you. I'm going to create a new track. Okay? And what I can do is, if I'm using this track, I'm going to hold down shift. And I can click maybe the front wheel. And then it's going to move to the next frame. And I'll hold down shift and I'll click the front wheel again. I'll keep clicking the front wheel all the way. You guys see what I'm doing? So look. It now tracks the position of the front wheel for at least those first 8 frames. Are we cool? All I did was I held down shift and I just clicked on the front wheel. I just told the computer, yeah, I just shift click, shift click, shift click. Is that annoying?
Yes.
That is incredibly annoying. And this is why I say that the free program is better than the original program, because I'll show you guys something cool that this program does. If I press Control and Shift, Control Shift, it will, instead of giving me a square, see that it gives me a square, if I hold down Control as well, it will give me this circle looking thing, and when I click it, I'll show you what it does. It will do an image search to track exactly where this thing is. You guys see what I mean? This is advanced tracker already. So what it's going to do is it's going to search in this. It's going to search inside of this box right here, and it's going to look for a picture that looks exactly like this, or something close to it. So that's why I have I say I want you to look for, you know, a picture that matches this. So watch this. When I tell it to search, it will look for that picture in that box, and it will say, "Oh, okay, that's new. That's a new point." I can even have it do it automatically and just go search, and it will go like this. It will search the whole thing. Now, I'll be honest with you. This technique works well on something like, you know, this thing where you can tell a very big difference between the front wheel and the back and the background. You know what I mean? But if you have if you're tracking the head of a person and they're running, and the background is a bunch of bunch of different faces, then the computer's gonna be like, "What the heck is going on?" And what you'll have to do is probably do it manually. You see what I mean? Or if you have a black spear gun and your spear is black, you don't want to do it in a black background, so that the computer will say, "I can't tell. Everything looks black to me." You know what I mean? So look, here's what we did. What we did was we tracked this. Okay, we just tracked the front wheel of this car as the time went by. Now, Jenna keeps asking, what is a frame? Is that what you're asking?
Like the smallest unit of film that you have.
Yeah, a frame is the smallest unit of film that you have. And usually your video cameras record like 30 frames per second or something like that. So notice how each time it advances the thing one frame and then tracks it. So so that's why this jump right here is 1/30th of time. You know, one frame is a 30th of a second. So at 0 seconds, the dune buggy was right here, and then one frame later, a 30th of a second later, it was right there, and then as a 30th of the second. So we're actually measuring motion right here. Yeah, and we're creating the illusion of motion by taking all these pictures and putting them together, so it looks like motion. But what we're doing is we're breaking this down and analyzing each thing, each piece. Are we cool with this? Yes, and the reason why they would use more frames per second is so that they can get an even more accurate analysis. You see what I mean?
Yeah, that's why in slow motion videos it goes up to 200.
Right. You want to go super high frames per second because you want to analyze it. If not, then you won't be able to analyze. If you take this thing and make it into slow motion, then it would just look all jerky and blurry and that kind of stuff, and that won't be cool. So if you want to have slow motion analysis, then you have to have a camera that can do higher frames per second. But for our car, 30 frames per second, works very well. So here's what I want to do: is you can actually do all of this analysis in. All right. So wait. First of all, does anyone have any questions about how I tracked this? I'll go over I'll recap it for you. But do you have any questions? Do you guys think this is cool now?
How did you get to the mass A part? Which button did you click?
All right. So what I did was, okay, I'll recap the whole process for you. In fact, I'll redo the whole process for you. So that way you can kind of be like, oh, okay, let's see. Okay, let me just delete the track that I made, and I'm going to delete the coordinate system that I have. I think I can just do that. There we go. All right, I'll show you everything I did. All right. So what I did was I started the video off here at the beginning, and then I put in a calibration stick, and I adjusted the calibration stick so that one end is on the end of the meter stick and the other end is on the other end of the meter stick. And actually, I think I got a little bit off. Let me see. I can zoom in. That's definitely the beginning of the meter stick. You guys agree?
Mm-hmm.
That's, you know what, we'll put it at the top. I would say that's the end of the meter stick. I'm just trying to get super accurate here. There we go. All right. So I set the meter stick up, and then I told it how long it is. So I could either put 1 in there, and that would indicate to me that this thing is 1 meter, right? Or if you wanted to measure things in centimeters, you could put 100 in there, and then that would say, oh, that's telling the computer that it's 100, you know.
Wait, why wouldn't it go to 100 meters?
Well, the computer doesn't know whether it's meters or 100 meters that you put in there, but you would know. Okay, so if you put in 100 there, just understand that you're telling the computer that that's 100, so it would just give you a bunch of random numbers.
Oh, so it doesn't.
And then you have to say, okay, this is 100 centimeters. You see what I mean?
Mm-hmm.
But I'm going to put in, let's put in 100. All right. Now what I'm going to do is I set up a coordinate system, and you can move your coordinate system around like this. You can even move it up and down, like that. I don't want to move it up and down, but what I do want to do is I want to move it so that it's at the beginning of my meter stick. Cool? And then I'm going to track this thing by create a point mass track, and I can press shift and click on that a whole bunch of times, and it will, you know, as soon as I click on it, it will advance to the next frame, and I'll tell it, okay, this is where it is now, this is where it is now, this is where it is now. Or what I could do is I'll press Control Shift, and I'll just say, I want you to take this picture right here, whatever's inside of this circle, and I want you to find it. And I'm going to adjust the box real quick, because I'm going to say, I want you to look inside of this box over here for a picture that looks just like that. Mm-hmm. And I want you to search for that. So watch this thing and see how it changes. The reason why it changes just a little bit is because this is what the picture looks like now inside of that box, but this is what one is trying to compare it to. So it's saying anything inside of this box over here, I'm going to look for something that looks like that. And then it says, hey, that looks like that. So that's what it finds. That's how it gets that next track. And you can have it do it automatically and just say, search the whole thing for me. And it will track out this whole motion for you. Now, I'll admit to you that I set up this video so that it's nice because I have a nice white wheel and a nice black thing. Now, look, you probably don't want to use this little, I don't know, what is it, the little flag on the back of your antenna on the back of your thing? Wouldn't you want to use that?
Oh, because it's off and on.
Yeah, because it changes color. So the computer's going to be like, all right, I'm going to look for this black antenna. And then every time it turns red, it's going to be like, where did it go? What happened to my antenna? You see what I mean? So we're tracking the motion. And all we're doing is we're taking a different frame, and we're going through each frame, and we're saying, okay, this is where that spot is. This is where that new spot is. You guys get it? All right. Now, here's what's cool. Now, I'm going to tell you now. On the video that you do over here, you can probably, it's nicely set up for that. But on the video you do at home, you might not be able to do it automatically. You might not be able to hold Control Shift. You might just have to hold Shift and press each one. You see what I mean? Mm-hmm. It's because, like, if I'm trying to track this ball and I have a white pad or yellow pad or yellow background, and all of a sudden the ball passes the yellow background, right? Then all of a sudden the computer will get lost, and you're like, where'd that yellow ball go? You see what I mean? So you might need to kind of like tell it where it went.
How big can like the image be that it tries to look for?
You can set it up however you want. You just adjust those little parameters.
So like if I was swimming, I could try to match it to my body since I already know that, you know, the swimming pool's like 25 meters or whatever.
Yep. You can totally do that. But here's the thing. I'm going to tell you guys some techniques for setting up your own video. You need some kind of calibration stick in there, okay? So I know that when you swim, they have the lane guides, mm-hmm. and part of that, the first part of that lane guide is like white, and that kind of tells, like when I was swimming, that kind of tells me to start my turn so that I can kick off the wall. Mm-hmm. And I know exactly how long that lane guide is, right. You know. So when you do that, also when you're doing your video, try to get it from the side. So you don't want to take a video like this. because you can't track that.
Okay.
You know, if you're saying, all right, I'm going to track someone throwing a baseball, then you don't want to be from the catcher's point of view, where you're catching the baseball, right? Because A, it will hit your camera, and B, you know, like you can't really track this, but you can track this. So you want to get a nice side view. You guys get it? So A, you need a calibration stick. You need a side view. Also, don't move your camera. Okay? Because I see this all the time. People go like this. All right, I'm going to track it. Ready? Go. And they go like this, right? But the problem is, since the background is moving and there is no reference point for the stuff to have, so you need a tripod. You need some kind of like either a tripod or sit your camera down on a table or something. Just don't move it. You could roll a ball. That would be a perfect experiment.
Yeah, I was gonna.
Yeah, that's all you need to do. That's all I'm asking you to do now. Roll a ball across the table, take a video, track it. Got it? All right. Okay, so I don't know what he's talking about. Anyway, what you're going to do now is I'm going to start asking you questions about, let's graph this thing, because this is really what I want to get into. I'm just using Tracker as some cool thing, but what I want to do is I want to graph something. In fact, I'm going to make a new little spreadsheet. So I'm gonna copy and paste that data, and here's the data right here. All I did was I just highlighted it like this and copied it, oops, into an Excel file or a spreadsheet file. Does anyone not have Excel on their computer? You don't?
I don't.
All right. What?
I can use a spreadsheet on Google.
But you have a spreadsheet though,
Yeah.
right? And if not, I'm actually doing this in a Google spreadsheet.
Oh, okay.
So let's see. The first column was time. This column was X and this column was Y. What does that mean? X and Y.
Oh, so they coordinate.
Yeah, this tells me the X coordinate and this tells me the Y coordinate. That's why each of these tracks have an X coordinate and a Y coordinate. Got it? So at time 0, this thing was at 3.4 centimeters and 3.71 centimeters as far as height goes. At time 0.1 seconds, this dune buggy was at 5 centimeters and 3.7 centimeters high.
Hey, why shouldn't have changed at all, right?
The X is your distance, the Y is your height, and what are you talking about the height, and what are you talking about? Because actually, you guys have a very good point. Let me graph something for you and then ask you about what you guys are talking about. The height of what? The height of, see, like this right here is where my height equals 0, along that purple line. That coordinate, this point right here, is not on that purple line. It's a little bit above that purple line. So it's just telling me how far above that purple line it is. That's all that is telling me. But you bring up a very good point. All right, so I'm going to chart this thing. I'm going to graph this thing. So all I do is I highlighted what I got, insert a chart. I want a scatter plot. Those are always nice. There we go. And I just say insert that. And there it goes, right there. So what I'm going to do is I'm going to move this guy inside the thing. So the blue lines are the X, the red lines are the Y. I'm going to try to make this thing a little bit bigger. What is a horizontal axis? Nope. Nope. It's not X. Nope. See, what it's doing is it's measuring these two lines relative to this first column. And that's in time. So at 4, this thing almost took 4 seconds. That's why time goes down to about 3.9 seconds. And it's plotting this. So this is the X plot as a function of time. All right. So I'm going to make these little dots smaller. And here's my question to you. Because actually, this is what part A of your homework is to do. Do exactly what I did and get this graph on your computer. That's not even hard. Because you can just watch this video and do exactly what I did. I'm just making sure that you understand how to do this. By the way, what is this? What is the y-axis? Yes, this is being archived, I think, I hope.
Yes. No.
I don't know. I don't know what this means. Or what does the left vertical axis mean? That's the distance. And what is it measured in?
You didn't even say.
What is it measured in?
Centimeters.
Centimeters. Why is it not meters?
Because 1 meter is the whole thing.
1 meter is the whole thing, and there's 1,000 or 100 centimeters of 1 meter.
Right. It's not centimeters because we set it up to be the calibration was measuring 100.
Right.
So this is measuring, like this is it's saying if this is 100, then this is 3 and 5 and and it goes up to about 100. You see what I mean? It's the reason why it's in centimeters is because that's how we set it up.
Mm-hmm.
If we ended up putting a 1 up here, if we ended up telling this computer that, hey, the length from here to here is 1, then we would know that this is a meter, and we would say, okay, the distance is now measured in meters. You know what I mean?
Right.
So I have a question for you. Now here's the part where so has this seemed like math? That's my question. Have we been doing math yet?
No.
Really?
Yeah.
I mean, there's numbers involved.
There are numbers, but I mean, is it math? Is it straight ahead math? All right, let's. You're right. So you're gonna have coordinate grids. All right, I've seen that in math. Not really. Meh. Okay, fine. Here's my question to you. Let's start talking about math and seeing what that actually means. Because in math, you're taught how to find the slope of a line. How do you find the slope of a line?
y2 minus y1 over x2 minus x1.
Yeah, you get 2 points.
I was like, what is it?
No, you're right. You get 2 points, and it's the rise over the run, right?
Mm-hmm.
You take 2 points, and here's one good point right here. This point is at...
Minus.
Here, let's find that point. The, 1 point is at t equals 3.9, x equals 1.0. Or this is now your x, and this is your y. So here's your y2, here's your y1. You guys get it?
Yeah.
Now let's find another point. It can be any of these points. Here's your x, and here's your y.
Mm-hmm.
So you take the difference in height, which would be this number, 101, minus that number, right? And divided by your difference in time, which would be this number minus that number. And it would give you your slope, right? Your m, right? And that's math. Ooh, math. But that's not even hard math, right? Yay, math. What does that represent? Like, why would we find the slope?
So you know how fast it's going. You know the speed or
How does that
velocity.
relate to the speed, though?
It's the slope tells you how much it's going per each point. I don't know how the technical term, but I know like the.
No, but that's exactly it. I mean, if Vernon, you think about exactly what Vernon's saying. Is like Vernon's saying, well, you're going to be measuring rise over run. When I'm measuring the rise, I'm talking about how far the x has changed, so that would be measured in centimeters, right? Yeah, and the run is your speed, is your time, so that would be measured in seconds. So you're talking about a distance per time.
Right.
Isn't that a speed?
Mm-hmm.
Like when your parents drove you someplace, they went 25 miles per hour, or maybe they went 50 miles per hour. Because they went on the freeway, or maybe they drive 50 miles per hour on the surface streets, which I mean is not safe. But I mean, hey, I don't judge. Actually, I do judge. And a judge will judge. So tell your parents to stop driving 50 miles an hour in a school zone. All right, whatever. So what I'm saying is this actually represents speed. So this crazy thing about the slope And you can calculate out what the slope is if you have the graph. You don't even need the graph. You can just have 2 points. So just choose any of these two random points. That will tell you how fast this ball is moving. Or not ball, this car is moving. Do you see how all of a sudden we've turned math as it applies to the world we live in? That's what science is, my friends. This is why it's important for me to teach you guys math. Why I feel like it's good for us to start learning math in our science class. Not because I want to hammer you guys with more and more math and more math. It's because I want to show you guys the awesomeness of math. It's so incredibly epic. And I'm going to do it in a way that hopefully you'll be able to appreciate this. Like, hey, now I actually want to learn how to calculate slope. Because it would actually help me actually calculate something. It's awesome yet boring. Okay, fine. Let's do some other stuff.
Brave said
Yeah. Thanks, Raven. I appreciate your enthusiasm. All right, you know what? I'm going to do this. Tracker. All right. Video analysis. I want to show you guys something. So do you guys understand I think it's Ball State University. Because Ball State University sounds funny.
Oh, see, it's an actual university.
Yeah, but hold on. I want to do linear motion. Hold on. All right, I want to show you guys something that I think is kind of cool. See, look, it's Ball State University, which is actually, this isn't Ball State University. Yeah, it is. It's called Ball State University. I don't know what the deal is anyway. All right, now let's see. Let's try this one. Let's do this one. I'm going to download this. The way I download this, I right-click it, I say Save Link As. Not All State University. Yeah. No. Raven was talking about the university that I asked you. Are you in good hands? No. All right. So you guys understand what the assignment's all about. So what I'm going to do is I'm going to do something else. I'm going to do a very simple thing. I'm going to show you guys something that I think will blow your mind. Well, it blows my mind. I'm going to do a very simple thing. I'm going to have linear motion. Linear motion basically means motion moving in a line. Is this linear motion?
Yes.
All right. It happens in less than a second. Is this linear motion? Yes. It moves straight down. It moves in a line. Hence Ball State University. Because we're talking about a ball. All right. I'm going to track it. I'm going to do a coordinate system. Now this time what I'm going to do is I'll set up the coordinate system to start here. I'm going to do a calibration stick. And it looks to me like he has a meter stick taped to his wall.
And how did you find out the mass of the ball?
So I'm going to put it there. The mass of the ball, he tells us, because he measured it he measured it on a scale. But let's see. I'm going to do a new track, and what I want to do is I'm going to try to see if I can get the computer to track that for me.
Oh yeah, that's good.
Although, see, the problem is,
It's pattern.
no, it's going to get blurry. It gets blurry as it
I
As
try
it
to track
moves.
the color.
Oh wait, the finger's in there though.
See, it's saying I can't find it. I don't know what. Okay, wait.
Oh, the thumb is in there too. His finger.
All right.
Finger
Okay, wait.
roll.
Here's what I'm gonna do. I'm gonna have to do it by hand. Click. And you know what? Get rid of that coordinate system for me so I can see it. Click, click. I'm gonna try to track the middle of that ball. But you see how it gets blurry?
Mm-hmm. Oh wow. Oh my god, it disappeared.
I know.
So
It gets
your head
crazy.
moved.
I'm doing my best here.
Looks like there's a goose.
I have to leave in 7 minutes. Remember, so. So do you see how actually I'm going to recommend to you guys that you track something kind of slow, or not necessarily even slow. You just back up. Okay. Now look at this. That is an ugly track. What is that? I don't understand. it kind of actually brings me up to a good point that I realized I didn't even ask you is the x-axis looks like that and the slope is that. Nolan was talking about the y-axis though. Why is the on the old graph, on the old one, why is the y-coordinates like that?
Well, because it just went straight. It didn't go
Right,
up
because your
or
y
down.
doesn't change. Your y didn't go up or down. So in this case, why don't we try, I'm just going to replace this graph and see what happens. There we go. Let's delete these ones. Because this is from the old graph right here.
And then try the new one.
And there's our new one.
Well, the red's the Y.
Okay, the blue is nothing. The red is the y-axis.
Is it dropped?
And it's going down. Yes. The reason why it's negative is because we're talking about it. It started here, and I told the computer that the origin started up there, and so it's saying, well, the next step after that was right below it, so that's why it's negative numbers, right? But darn, doesn't that look like a shape to you? And what kind of shape? Oh my goodness, it's a parabola. Disregard the x one. Look at the y values. What is that?
Half of a parabola?
It's half of a parabola. Parabolas describe the world we live in. It's a parabola. So do you understand how me wanting to teach you about complete the square or a quadratic equation is actually relevant because it's describing the world we live in? Doesn't that blow your mind? I mean, I wasn't even doing any kind of trickery here. All I did was I tracked this thing. You know, I can even go back and show you. Look, I did my best. And look what we have. Okay, by the way, the reason why this thing looks like it was such a weird graph is because we're graphing the x-coordinate, but if I graph the y-coordinate, look what we got.
Wait, why would the x-coordinate do that?
The x-coordinate is going all over the place like that.
Yeah.
Going like this. No.
It's because it's really kind of going a little bit to the right and left. But look at also how zoomed in we are. We're going from -0.2 to 1.4. You know, whereas on this one we're actually zooming out. So this right here is a parabola. Parabolas are totally relevant to our lives. And in the next couple of weeks, I'm going to show you how to analyze that. In fact, I'm going to show you what I really want to do is build a ping pong ball launcher that I saw in Khan Academy video that
I got that email.
just sent me, Victoria. And then what I want to do is I want to try to develop sniper ping pong ball launchers. And what I would really like to do is oh, here it is.
I remember seeing that video.
What I'd really like to do is this. This is a cannon. It's a mini cannon. It fires mini little ball bearings. I also have a giant table set outside that has army men, the little green ones, set up all over the place. If I teach you guys the fundamentals of projectile motion, of parabolas, of understanding how to analyze parabolas mathematically, we can calculate this thing out so we can basically sniper all of those little green army men. Using a paintball gun, using a ping pong ball launcher, using a mini cannon. That's what's cool about mathematics. Using a BB gun, sure. Why don't we do this? Hopefully in a safe setting.
Yeah, I don't think BB guns would be that safe.
I like what Raven says though. Pew 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 pew. You know what's funny is
That's not how you spell BB gun, Raven.
You know what's really cute is my son. He's 1.5, so he's a little baby. My little baby son. He just learned the he goes. So he's learning that. So he runs around the house and goes. And I'm like, oh, that's so adorable. I love him so much. Anyway, all right, whatever. Get out of my sight. You guys are done. Talk to you guys later. Do you guys understand what your homework assignment is?
Yes.
Your homework assignment is to analyze the dune buggy. And after you analyze your homework assignment is to analyze the dune buggy, send me the graph. Basically do exactly what I did for you in class. I just want to see that you can do it on your own. The second assignment is to make a video of you demonstrating linear motion. You could roll a ball across a screen. You could have Nolan push you in that chair and then have a video and then you rolling by and saying, "Hi," and then basically going through the script. Yeah. All right. Anyway, talk to you later. Okay, bye.
Thanks for using web.